This is Further Pure Maths, Pearson Edexcel IGCSE from January 2022, paper 2R. Let's just do this then. So, just take away 4x, add 10 to both sides. You get this. This one you need to factorize this, or you could use quadratic formula. In either case, you get critical values of a half and 5. We want to be in between the two critical values because you're being less than 0. If you want to, you can draw a graph of this to make sure that you definitely know that. So if you draw the little quadratic graph, you have roots at a half and 5. It goes underneath them through there, so to be less than 0, it's between the two roots. Anyway, both these things being true, so we need to be both bigger than 3 and between a half and 5. That's going to be between 3 and 5, I think, if we collect those together. Good. Question 2 then. So we've got an equation that goes through A and B. I thought I'd do this question a bit weirdly. So just y equals mx plus c is a line. We know that x is this when y is this, so we'll plug that information in first, and we know x is this when y is this, and we've just created a simultaneous equation in M and C. Do this one, take away this one, 3 minus minus 7 is 10, 4 minus minus 1 is 5, you get M is a half, and then you can substitute a half into there, and you get C is 5 over 2, which you can then write into here, so the equation is y equals a half x plus 5 over 2, double everything, take away x, and then take away 5 over the 5, and you'll end up with this here. C has coordinates this, given this, so A to B is going to be, just Pythagoras here, the distance from minus 7 to 3 is 10, and the distance from minus 1 to 4 is 5. So I would suggest drawing this down and putting the points down and doing some Pythagoras from there, but I just couldn't be bothered. So A to B, the distance is just 10 squared plus 5 squared square rooted, which is this, and the distance A to C is just going to be, well, from here to here is 4, and from here to here is 8, so that's 4 squared plus 8 squared square rooted, which is this here. What do we have to times this one by, A to C, to get this? Well, I think if I times it by 5 over 4, I'll get this, because the 4's would cancel, timesing this by this, and you'd end up with a 5 here. And the root 5 will obviously just stay the same. Point D has coordinates 3p, where p is constant, CD is perpendicular to A to AB. The gradient A to B is going to be y1 minus y2 over x1 minus x2, or the other way around, it doesn't really matter. As long as you do this minus this over this minus this, these things add, you end up with gradient a half. So the perpendicular therefore has gradient minus 2. So the gradient C to D, the C to D has gradient minus 2 there, negative reciprocal of this. And then we can just set up the same thing from C to D here. So this minus this over this minus this. And that's going to be the minus 2 because we know it's the negative reciprocal of this one here. This is minus 6, times both sides by minus 6, we get this. And then you can say P is minus 5, I think, from there. And we'll have our answer. Good. Question 3 then. So some product rule then, I guess. If we write this as this first, differentiate this one for 2 e to the 2x, leave that one alone. So that's what I've done there. And then leave this one alone and differentiate this one by chain rule. This is a half, comes down to the front. The derivative of the inside is just 5, so that's where those two things come from. Then you keep this as it is and take away 1 from this to get this here. Couldn't even bother to simplify it. This one you could do quotient rule, but you know that I won't. I'll just do this and do product rule again. So derivative of this is 3x squared, leave this one alone. And then leave this one alone, and the derivative of this is minus 1. Then put the minus 1 down. Derive this to 3 sine 3x with a minus, because cos differentiates to minus sine. And then, of course, you make that a minus 2. And you can simplify that if you want to, just because it felt wrong not to, I guess. But I don't think you'd lose marks if you didn't. 4 then, so alpha and beta are the roots, which means alpha plus beta is minus 4 over 2, which is minus 2, and alpha times beta is 3 over 2. So the sum of the roots is just minus this over this, the product is this over this. That's just the rule you need to know for this exam, apparently. And yeah, now we are good to go. Let's just square both sides of this equation here. So alpha plus beta all squared equals minus 2 squared, which is 4. We can expand this out. 2 alpha beta is just 3, doubling this equation here. So that just gets replaced with a 3, and we end up with what I wanted us to do there. Find this here. Well, just take this thing here and square both sides again. And we'll do this times itself, right? So alpha squared times alpha squared is alpha to the 4. Alpha squared times beta squared is alpha squared beta squared. But there's 2 of those because of the other term, and then beta to the 4 at the end. So we get this. 1 squared is just 1, obviously. So just square this equation here. Alpha squared beta squared. We'll just square this, right? Alpha squared beta squared is going to be 9 over 4. But then, of course, you've got 2 of those. So 9 over 4 times 2 is 9 over 2. And then do 1 minus 9 over 2, and we end up with this here. Hence, form a quadratic equation that has coefficients of this. We're just doing this thing that I talked about backwards here, right? So the equation that we'll form will have, if the roots are this and this, alpha to the 4 plus b to the 4 will be this number over this number, regardless of what numbers we've got, also with a negative in there as well, for the same reason that was here. And alpha to the 4 times b to the 4 needs to be this number over this number, whatever our numbers are. But I think we can immediately work out what alpha to the 4 b to the 4 is, because we could just raise this to the power 4. And so we're looking for some coefficients here where we're going to get this over this is 81 over 16. So surely I can just use 16 and 81, right, as my first coefficient in my last one. Except this is going to, because we've already got the plus alpha to the 4 plus b to the 4 here, that's going to be this one over this one, right, with the negative. But this isn't over 16. But that's okay, because I can just times these by 8, and I'll get it over 16. And now I think I just need to write this one here, because just to run through this, alpha to the 4 times b to the 4, if those are the two roots, is going to be this one over this one, which is correct. And alpha to the 4 plus b to the 4 is going to be negative this one over this one, which is also correct. So that's kind of how we can reverse engineer that. Anyway, we've got some information about series here, so that's cool. Sum to infinity is this one, so it's literally just 12 over 1 minus that, type it in the calculator. The sixth term of G, now a geometric series starts A, then goes AR, then AR squared, and so on. So this is the first term, the second term, the third term. Notice how the terms are just one less than the term number as the power of R. So first term, second term has power 1, third term has power 2, sixth term is A to the power 5. A is 12 and R is 3/8. Now 12 is 2 squared times 3, doing a prime factorization. And of course 8 is 2 cubed, which means now we can now do 3 to the 5 and 2 to the 15 on the bottom here. And now this 3 is 3 to the power 1 times 3 to the power 5 is 3 to the 6, that's on top. And we've got 2 to the 15 on bottom, 2 to the 12, 2 on top. So cancel out 2 of those with 2 of those to end up with 2 to the 13 on the bottom, and we end up with what they wanted us to get. The nth term is used the n here, or un, I should say, actually. Now, like I said, the sixth term is AR to the 5. So the nth term is AR to the n minus 1. And that's cool. A is 12, R is 3/8, so that's fine. We can just do that. We can write them in their prime factorizations again, so I'm just doing the same thing I did before. Now, this is 3 to the power n minus 1 times 3 to the 1 is just 3 to the n on top. This is 2 to the 3n minus 3. And then you remove 2 from that, because there's 2 here, just like we removed 2 from these 15. So I think that creates 3n minus 5. Just go through that if you want to again in your head. But we get 3n minus 3 from here. And then we deduct 2 more from that, because for the same reason that we took away 2 from this here, because there's 2 cancelling out, 2 of them at the top here cancelling out with them, so we end up with this. And you can verify when n is 6, this becomes this, I think. So I think we're definitely fine about this. Anyway, so that's that. So log to base 2 of this, let's consider. Now, of course, log laws, we can just do this one, log of this one minus log of this one. Now, power law says the n can go there, and the 3n minus 5 can go there. But of course, log to base 2 of 2 is just 1. And then you expand out this minus, and you get exactly what they wanted us to get. I thought that was a really cool question, actually. So yeah. This is 4x to the power half. We're talking about tangents. Let's immediately just differentiate this. There we go. Using the same chain rule we saw before, I guess, or just product power rules, I guess. The tangency at A, so it's tangent, so it's at A, x is 9. So let's just substitute x is 9 in here to work out the gradient of this thing at the point 9. And 9 to the power minus half is a third, so 2 times a third is 2/3. And so that's the gradient of the tangent, and then we can just use y minus y1 equals mx minus x1. And I'm not even bothering to sort this out, because it just tells us that that's the equation of the tangent. I could do stuff with that. But it tells us it actually just wants the point where the tangent meets the x-axis. Things meet x-axis when the y-coordinate is 0. So I can just shove y as 0 into this, and then start solving for x, and we eventually end up with this. Right, times by 3 is minus 36, minus 24 when you divide by 2, and then add 9. Oh, sorry, minus 36, minus 18 when you divide by 2, add 9, and we get minus 9. So yeah. So that's just I guess the coordinates to here, minus 9, 0. We already said y has to be 0, so minus 9, 0, I probably should have written up here. The normal to C, well, the normal to C is gradient minus 3 over 2, because it's at the same point, and this times this is minus 1, or just the negative reciprocal of that. And we can just do the same thing. Y minus y1 is the same point, right? So y minus y1 equals mx minus x1. I still can't be bothered to do anything with this. I'm literally just going to put y as 0 in again, because I'm still looking for the point where it hits the x-axis. And we solve that, and we get this. And now calculate the area of the triangle ATN. Well, finally we can draw this. I should have drawn this much earlier, but here's this line here with gradient 2/3 intersects the x-axis at -9. Here's this line here. This line is this one over here. Gradient -3/2 intersects at -17. And we're looking for the area of this triangle here. Now, this is just 26 across. This is 12 up by definition because the y-coordinate is 12. Half times 26 times 12 will get us the answer of 156. Question 7 then. So let's times both sides by this denominator, and let's expand out. Also write sine squared as 1 minus cos squared, and expand that out, and we end up with this. And then, of course, we can add this and end up with 0 over on this side. Divide everything by 2. When you've got a quadratic like this, you can make a proper substitution in your head if you want to, but just in your head, think about what this would factorize to, because whatever this factorizes to, this is going to factorize to the same, just with cos thetas instead of the x's. Eventually, you realize it goes to this, which of course is great, because this means that cos of theta is -1/2, which is the one they wanted us to get. This one is cos of theta is 2, but cos of theta of 2 has no real solutions, so this is the only one we'll actually have. Hence solve this here. So all this is this one with theta being replaced by 3x every time. So let's just take this and replace theta with 3x, and we end up solving this. Do cos inverse, and we end up with this is what the calculator gives us. But of course, there could be multiple solutions. So get out the cos graph, and 120 is the solution they just gave us. So that's 30 forwards from 90, so let's go 30 backwards from 270 by symmetry to get 240. And then the next solution way over here somewhere is just when you add 360 to this. So add 360 to that to get 480, and then add 360 to this to get 600. I notice if I divide that by 3, which is of course what I'm going to do to solve for x, it's going to be 200, which is out of bounds. So just these 3 count, and divide all that by 3, and we end up with these solutions there. Question 8 is a nice question as well. So circular stain, so the area of that is going to be pi r squared. T is 0, A is 0, because it starts, the liquid starts at that point, so there's no area to start with. The area of stain increases at a rate, so dA by dt is 1.5. Find in terms of pi the radius at t is 4. So all we have to do here is say, well, the area was 0 when time was 0, and it increases by 1.5 every second. So all we have to do is say it's 0 plus 1.5 times 4, right? The area was 0 to start with, plus 4 seconds worth of 1.5 increase makes an area of 6, and then just put that 6 into this formula and solve for r. And they wanted it exactly in terms of pi, so it's just going to be this here. Now find the rate of which the radius is increasing at t is 4. So we want to find dr by dt at t equals 4. So a couple of intelligent things to do here. Find dA by dr by just differentiating this, which turns out into this, which is cool. And now how can we find dr by dt? Well, let's just set up some intelligent fractions. Dr by dt is dA by dt times dr by dA, because these dA's would cancel, and you should just be left with dr by dt. But dA by dt is just 1.5, and dr by dA is just this flipped over. So we can put both those figures in there. This is 3 over 2, which makes this 3 over 4, and we end up with this expression for dr by dt. Now, for a moment, we think we've made a mistake here, because they've only given us the information that we want this at t is 4, but there's nowhere to put the information of t in here. That's okay, because you worked out what r was when t was 4. It was this. So that means we can equivalently put this result into here, and we'll find to decimal places this as the result. Question 9 was probably the most interesting one here. It starts off saying tan alpha is this, find the exact value of cos alpha. Now this is cool, right? Tan alpha is opposite over adjacent 2 over 3 with a right angled triangle. Do some Pythagoras to get this, and therefore cos alpha is 3 over root 13. Now that's usually a really nice thing to do, except this is a calculator paper, so it's going to turn out completely pointless. Absolutely irrelevant to everything we're about to do, because of the absolute stupidity of both these papers, paper 1 and 2, both being calculator allowed. Sorry, I just let that go the better of me for a second. But genuinely, question 9 and 10 in this paper could have been so cool to do, but they gave you a calculator, so it was really boring, and I just don't understand. Anyway, we've got a pyramid with rectangular base. They want us to find out the value of h. This is nice and straightforward. This length here from A to C, because this is a right angle, because it's a right angled base, if you look from above, it's just a right angle, so it's just a rectangle, so this is a right angle. So A to C is just root this squared plus this squared by Pythagoras, which is this. So that's A to C, which means O to C is just half of that, which is just 15. And then we can just do, looking at this triangle here, some more Pythagoras, 17 squared minus 15 squared square rooted. If you don't just recognize the 8, 15, 17 triangle, you're a bit of a pleb. But anyway, h is going to be 8 for that answer there. Now the size of the angle between the plane EBC, which is this plane here, and ABCD, which is the base, is theta. So if you draw a line straight down to the middle of BC and then straight across to O, and that's kind of how you have to do angles between planes. You have to go to the middle of this one and then across to the middle of that one. The angle they're talking about is this one, theta here. Now this distance is clearly 12 because it's just half of 24. And now we can just do, I mean, this is 8, right? So cos theta is just 8 over 12. Sorry, tan theta is just 8 over 12, opposite over adjacent. 8 over 12 simplifies to 2/3, and you're done. The point P is the midpoint of EB, so that's like here somewhere. And Q is the midpoint of EC, so that's like here. Find the angle between the plane OPQ, so that's kind of a plane coming out this way through these points, and the plane BCPQ, which is essentially the same as this triangular plane across here, is it not? That we were looking at before. Now again, this is all about midpoints of things. So draw a line goes to the midpoint of these two things here, and then down to the midpoint of BC. And what they're really talking about is this angle here, connecting those two lines, because that's the representing the plane going through O and the two X's, and then the plane coming up this side of this triangle here. So we're looking for this angle here. Now I can draw another length down here. I still know that's 12 because it was before. And now there's lots of things that I know here. This angle here is actually the same one we were looking at earlier. It's just theta, that same angle we had before. If I go back, it's just that same theta that they defined there. I'm stopping it early, but that doesn't do anything to the angle, does it? So that's just still theta. And now there's a few things you can think about doing here. I thought about just trying to find some extra lengths and doing sine rule, or both extra lengths and doing cosine rule to find alpha, which is what I'm interested in, obviously. I think all of that would work. What I actually did was I said, if you look at what triangle am I even considering here? I'm looking at this triangle down here, across here, and up here. So from E to B to the midpoint of BC is here, which is obviously 9 across because it's the mid of 18. So I think this length here by Pythagoras is that. And then this length here is therefore half of that because these points are halfway up the face here. So this is going to be half of the total thing. So that's 2√13. And then I realized actually, if you draw a line down here and then across here, like this length is 4, again, because it's just half of 8. This triangle here is just similar to the big triangle all the way up here, but it's just half as big because these are the midpoints. And then this length across here is just 6, right? Because it's half of 12. Again, triangles being similar. But that's quite cool because we know tan theta is 2/3, which is the same as 4/6. So this angle here, because that's a right angle, is just theta, because tan theta is 4/6, which is the same as it was before. So this is just theta as well. So this is actually an isosceles triangle, which is quite cool. It allows you to do this question quite quickly, because you can just do alpha is 180 minus 2 lots of theta, where theta is just tan inverse of 2/3. And again, this is why I said the whole, why have I got a calculator to do this? There could have been some really intelligent ways of me writing that, using maybe some extra rules and stuff like that. But no, just going to type it in the calculator and be forced to do it like that. Really, really weird. I just don't understand. Anyway, another question here that would have been really nice without a calculator, but is rendered fairly trivial with that one, which is just pointless. We're looking for the coordinate A and B, which are the intersections of these two curves here. So we just set this equal to this. The ones cancel. When does sine of x equal cos of x? Well, that's at pi/4 and 5pi/4, but you can just divide by cos of x to get tan, and then do tan inverse of 1 to get those two same results, I guess, if you want to. Anyway, so that's at pi/4, that's at 5pi/4, which is good, so we're good to continue. And then it says R and R2 is, so R1 is this and R2 is this, and we want to find the ratio here. So we need to find the two R1s and R2s. So R1, just think about this carefully, is the integral of C1 between A and B minus the integral of C2 between A and B, because the integral of C1 between A and B will give you everything underneath that curve. And if I remove this little area here down to there, and all of this area down there, I'll get R1, and that's just the integral of C2. So I think I can do this. The bounds are the same, so I can combine them up. The 1 minus 1 cancels to get this. Then do some integration. Cos integrates to minus sine. Cos integrates just, sine integrates to minus cos. Cos integrates straight to sine. And then, yeah, this is what I was saying. This would be actually quite interesting if you weren't given a calculator, but you are. So that's really boring, and you just end up with this answer as long as you're capable of typing something correctly. So that's R1. And now R2, what I decided to do was split it down here and say R2 is just the integral of C2 between pi and 5pi/4 plus the integral of C1 between 5pi/4 and 3pi/2. So I'll do that. And you can't combine these, so you just got to integrate them properly. Again, this would be really interesting without a calculator, but you have one, so I don't know why I went to all these lengths. I think I was just desperate to actually do some proper maths. You end up with R2 as this eventually, and then you can do this dot dot this because they're looking for the ratio of the two. I times everything by root 2 here. Root 2 times this is just 4 because it's 2 times 2. And then you times this by root 2 times this by root 2 and you get this. And that's all integers. So I'm happy with my answer there. The last question is about vectors. So it's going to be a banging question because these vector questions are always great. They give you that this is A and they give you that all of this is B. But I'll immediately split that into 2/3 B here because that's ratio 2 to 1 there. So this is B, but this is the midpoint here. So that's going to be a half. Sorry. So this is 1/3 B. And then the midpoint makes this 1/6 B and another 1/6 B there, which I am going to start using. Now, I did this question in a completely ridiculous way, but I think it's good because it just shows how many various options there are to do a question like this. But you can basically go however you want as long as you just follow vector rules. So what I said was, firstly, A to B is clearly just minus A plus B, which means, then I said A to C, I think I started talking about, is minus A plus 2/3 B, which means A to N is just half of that because N is the midpoint. So A to N is just half of this, which is that. And also, that's also N to C, right? Because it's going in the same direction and it's half, so they're both equal. So that's also N to C, which I'll use in a second. But I've got A to N then. And now what I'm also going to say is that A to M, A to M down there is minus A plus 2/3 B plus 1/6 B, or plus 1B minus a 6. Either way, you get 5/6 B. And now A to P, therefore, now P we don't have any information about other than that it's the intersect. So therefore, A to P is just some scale factor, because this is a straight line, is just some scale factor of A to M. So A to P is just K amounts of this vector up here. It's just K amounts, because it's like, looks like it's roughly 60% of this vector here, so 0.6 of AM. But of course, we'll find this amount later. To do that, I'll need to find another way of describing A to P. So what I used was I already had N to C, so I thought, okay, let's use more of that. So N to B is N to C plus C to B, which is just what we said before here, plus 1/3 of B, which makes this. And now N to B is that. N to P is just some amount of that. I'll call it M. Just some amount of M to N to B for the same reasons that this one worked out as well. Which means finally, A to P is going to be A to N, which I already have, plus N to P, which I already have, and A to P is going to be given as this thing here. I just multiplied out the M's there. And then A to P is just A to N, which I described here. Put it here, so that one's there. And then plus N to P, which is this one here. But of course, now I have two descriptions for A to P. This one here and this one here. They must be the same because they're representing the same vector. I'm going to group the A's and the B's for A to B here, because that means what I can do is I can say the amount of A's here, which is minus K, must be equal to the amount of A's here. So therefore we get this. And the amount of B's over here, which is 5/6 K, must be equal to the amount of B's over here, which is this. And this is a simultaneous equation. Times this by minus 2, take away 1, put it into here, times everything by 6, I think I did, and then do some solving. K is this. And of course, if K is that, you can just put it straight into there to find out A to P is minus 2/3 A plus 2/3 times that is 10/18, which is 5 minus B. And then that's A to P finally. And so therefore, O to P is just going to be A plus that thing there. A plus this. A plus this is just 1/3 A plus those B's. The point Q is the midpoint of A to B, so that's there. Now A to B, remember, was just minus A plus B. So therefore A to Q is a half of that because Q's in the middle. So it's minus a half A plus a half B, so that's cool. Which means I can write C to Q as, well, I can go minus 2/3 B plus A plus what I just found, and that'll be C to Q. I can simplify all that up and I'll get this here, so that's C to Q. And now C to P, I think I can just do minus 2/3 B plus what we just found from O to P, what we just found here. So C to P is minus 2/3 B plus what we just found. Now, usually it's dangerous to use results that you used before, but I did this on purpose because, you know, I know what I'm looking for when things are collinear. If it doesn't end up how I want it, that means I know that I'll have made a mistake on this. And so by using this for this next part, I'm actually double checking my work that I did before. Anyway, I simplify C to P to get this. And now if I factorize out a 6th from there, I'll get this. And if I factorize out a 9th from here, I'll get this. And therefore, they're both multiples of 3A minus B. So they're parallel. and they both originate at C, so they have the same origin point. And if they're parallel and start at the same point, then they must be collinear on the same line. And that's all we need to do. And that's the end of the paper. Thanks for watching, and I'll see you next time.